An alternate description of a black hole in terms of what's known as the holographic description. It's as if there's a two-dimensional world that surrounds any given three-dimensional world.
Are you ready to witness one of the greatest discoveries in the history of science? For decades, black holes have remained one of the most mysterious and awe-inspiring objects in the universe. Their immense gravity, which is so strong that even light cannot escape it, has kept scientists in the dark about what lies beyond their event horizon. That was until now. After years of waiting and hoping, scientists have finally made a breakthrough. They have managed to capture images of the interior of a black hole for the very first time. This is a monumental achievement that has been years in the making. It opens up a whole new world of possibilities, not just for the scientific community, but for all of humanity. What secrets will we uncover? What new insights will we gain into the universe and our place in it? In this video, we will take you on a journey into the heart of a black hole, revealing the mysteries that have eluded us for so long. You'll get an inside look at the technology that made this breakthrough possible and hear from the scientists who made it happen. You'll learn about the incredible forces that exist inside a black hole and how they shape the very fabric of the universe. So, if you're ready to go on a journey to the very edges of our understanding of the universe, then be sure to stay tuned till the end. We promise it will be an adventure you won't soon forget. Black holes have been a fascinating topic for scientists for decades. These mysterious cosmic objects have a strong gravitational pull and are formed when the remnants of dead stars collapse. But what really happens inside a black hole? For the first time ever, astronomers have peered inside a black hole and made a startling discovery about its contents. Using advanced imaging techniques, researchers were able to see powerful jets of energy and matter extending from the center outward. This groundbreaking discovery provides new insights into the nature of these enigmatic objects. But let's backtrack a bit. What exactly are black holes? Black holes are like giant cosmic vacuum cleaners that suck in anything that gets too close to them, including light. They are formed when the cores of massive stars collapse under the force of their own gravity, creating an incredibly dense point in space known as a singularity. The gravitational pull of a black hole is so strong that nothing, not even light, can escape it. This is why black holes appear black, as they don't emit any light that can be detected. There are three types of black holes: stellar, intermediate, and supermassive. Stellar black holes are the smallest and are formed from the remnants of dead stars, while supermassive black holes can be billions of times more massive than the Sun and are found at the center of most galaxies. You might be wondering what will happen if someone accidentally falls into a black hole. If someone falls into a black hole, the prognosis is not good. As they approach the event horizon, the gravitational pull becomes stronger and stronger. Eventually, they reach a point of no return, where the gravitational pull is so strong that nothing can escape, not even light. Once they cross this point, they are doomed to fall into the singularity, the central point of a black hole, where all matter is crushed into an infinitely small point with infinite density. As they get closer to the singularity, the tidal forces become stronger, which means that different parts of their body experience different gravitational pulls. This causes a process known as spaghettification, where they are stretched and compressed from head to toe, like spaghetti. Eventually, they will be torn apart into individual atoms, and their remains will be crushed into the singularity, never to be seen again. In recent years, scientists have been studying black holes using some really innovative techniques, including the use of holograms. They are exploring the concept of holographic duality, which suggests that black holes are actually holograms and their properties are interconnected with the surrounding universe. Additionally, researchers have detected nearly 100 emerging black holes through the detection of gravitational waves, which are ripples in space-time caused by massive cosmic events. These measurements have helped to improve our understanding of the universe and to test the limits of Einstein's theory of general relativity in extreme environments. A hologram is a three-dimensional image that appears to be floating in space and is created by using laser technology. In the case of black holes, the idea of a hologram is that the information contained within the black hole is actually spread out across its event horizon, which is the boundary beyond which nothing can escape. This means that the information about what went into the black hole is preserved, even if it appears to be lost. The holographic principle suggests that the three-dimensional universe we perceive may actually be a two-dimensional hologram, with all the information contained in a lower dimension. This is a mind-bending idea that challenges our understanding of reality, but it has gained support from recent studies that explore the connection between gravity and particle physics. The technology that made it possible for scientists to finally see what's inside a black hole is called the Event Horizon Telescope. The EHT is a network of telescopes around the world that work together to create a virtual telescope the size of the Earth. This allows scientists to see the details that would not be possible with a single telescope. The EHT works by observing the radio waves emitted by matter as it falls into a black hole. These radio waves can be detected by telescopes on Earth, but they're extremely weak and difficult to observe. To make matters worse, the radio waves are scattered and distorted by the gas and dust surrounding the black hole. To overcome these challenges, the EHT uses a technique called interferometry. Interferometry combines the signals from multiple telescopes to create a more detailed image than any single telescope could produce. This is done by comparing the phase of the radio waves detected at each telescope. By combining these signals, the EHT is able to create a virtual telescope with a resolution equivalent to a single telescope the size of the Earth. The first image captured by the EHT in 2019 was a breakthrough in astronomy. It showed the shadow of the supermassive black hole at the center of the galaxy Messier 87. The shadow was caused by the bending of light around the black hole's event horizon. This image provided the first direct evidence for the existence of black holes and confirmed many of the predictions of Einstein's theory of general relativity. It also allowed scientists to study the behavior of matter and energy in the extreme environment around a black hole. The idea that black holes and the universe as a whole could be holograms is a fascinating concept that is being explored in the field of physics. The study published in the journal PRX Quantum aimed to probe the concept of holographic duality, which posits that the theory of gravity and the theory of particles are mathematically equivalent. In other words, what happens mathematically in the theory of gravity also happens in the theory of particles, and vice versa. One of the main challenges in physics has been to connect Einstein's general relativity theory, which describes gravity, and the standard model of particle physics, which describes the behavior of subatomic particles. Enrico Rinaldi, a research scientist at the University of Michigan, and his team used quantum matrix models to connect these two theories and probe the concept of holographic duality. The researchers used matrix models made up of blocks of numbers, a standard framework used in quantum computers to represent particle theory as one-dimensional strings. By connecting these two theories and using quantum matrix models, the researchers were able to gain insights into what the gravity inside a black hole looks like. This could help us better understand what's inside black holes and how they behave, as well as provide insights into the nature of the universe as a whole. The idea of the universe as a hologram suggests that everything we experience in the three-dimensional world could be a projection of information that exists on a two-dimensional surface. While this might seem like a strange idea, it has been gaining traction in the scientific community, and many physicists believe that holographic duality could be a key to unlocking some of the biggest mysteries of the universe. The concept of a hologram in this context refers to the way the inside of a black hole interacts with the outside. According to the theory of gravity, the inside of a black hole can be represented in 3D space as space-time moves through it. However, on the surface of the black hole, it appears two-dimensional. This gives it a holographic appearance, as it does not appear as a 3D object. The idea of holography suggests that the information about the black hole's interior is encoded on the surface, which is only two-dimensional. This is because the theory of particles does not work in 3 dimensions. Therefore, some scientists speculate that the rest of the universe could work in a similar way, with the information about the universe encoded on a two-dimensional surface. However, at present, there is no concrete evidence to support the idea that the entire universe is a hologram. The study by Rinaldi and his co-authors is an attempt to explore the idea of holographic duality and understand what is inside a black hole by combining the theories of gravity and particle interactions. By using quantum matrix models, they were able to describe what the gravity inside a black hole looks like, and their findings may offer new insights into the nature of the universe. In conclusion, the discovery of what's inside a black hole is a major breakthrough in our understanding of the universe. For years, scientists have been trying to solve the mystery of what happens beyond the event horizon of a black hole. And now, we finally have a glimpse of what lies within. Thanks to the advancements in technology, particularly the Event Horizon Telescope, we can now see the unseeable and explore the depths of the cosmos in ways that were once impossible. This discovery will undoubtedly lead to even more exciting discoveries in the future and will continue to push the boundaries of our knowledge about the universe. As we continue to uncover the secrets of black holes, we will gain a deeper understanding of how they shape the cosmos and perhaps even unlock new technologies that will allow us to explore the universe even further. That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about the inside of the black hole? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.